Let us learn how to use NumPy for mathematical computing. NumPy or numerical Python is the foundational package for mathematical computing in Python. It has a huge set of built-in functions. NumPy supports fast and efficient multidimensional arrays, which are also known as ND arrays. It executes element-wise computations and mathematical calculations. NumPy performs linear algebraic operations, Fourier transforms, and random number generation. It has tools to read and write binary or text data from and to disks. It can efficiently store and manipulate data. Last but not least, it has tools to integrate language codes, such as C and C++. We will learn about ND array in detail.
An array is a collection of values that can be added, removed, and deleted just like a list. But unlike a list, it is homogeneous, that is, it can hold only a single type of data. It's also multidimensional. It supports mathematical functions and is fast and efficient. Before we go into more details, let's try to understand how ND array is actually used. For data scientists, it all starts with a problem or a question and a dataset. They then write a program to solve the problem or answer the question. A program can have multiple algorithms that contain business logic, such as functions or element-wise computations or mathematical operations. Algorithms within a program need to share data to manipulate it and execute the embedded logic. An ND array makes this task simple. It's used as a primary container for the data and is available throughout the program for fast and efficient computing. Arrays can be one-dimensional, two-dimensional, three-dimensional, or multi-dimensional. The best way to visualize an array is as rows and columns. You can also look at it by its dimensional axis or rank. You can think of a one-dimensional array as a single row of values. So a one-dimensional array has one axis or rank 1. Two-dimensional arrays can be visualized with rows and columns. This means that it has two axes or rank 2. A three-dimensional array has three axes and can be visualized as a cube, which has height, width, and length. Similarly, multi-dimensional arrays have multiple axes.
NumPy also provides a large number of mathematical functions. They are called universal functions or ufunc and are fundamental objects in NumPy. These functions operate element-wise on any given array and create another array as the output. These includes functions such as sqrt, which provides the square root of every element in the array, cos, which gives the cosine value for all elements in the array, xp, which performs exponentiation on each element, and floor, which returns the largest integer value of every element in the array. Some examples of common ufunc functions are given on screen.
The shape of a basic array can be changed according to the requirement using NumPy library functions. These array shape manipulation methods really come in handy during the data wrangling phase and is used extensively by data scientists. Following are some common methods for manipulating shapes: flatten, resize, reshape, stack, split. Let's look at each in the following screens.
Let's look at each of these shape manipulation functions using the example given below. The ravel or flatten function flattens the dataset into a single row. Reshape is a function which reshapes the dataset. Here, the dataset is reshaped from 2 rows and 6 columns to 3 rows and 4 columns. The resize function resizes the dataset back to its original dimensions, which is 2x6. The split function splits the array into 2 in the given example. Both the arrays now contain 2 rows and 3 columns. The stack function shows how one can stack the 2 arrays together.